Hello ladies and gentlemen, and thank you for listening to Mr. Laxton's video on these 6.8 Algebra 2 notes. So today my central question is, how am I going to graph polynomials? Alright, so how am I going to graph polynomials today? We're going to look at taking these zeros and taking the solutions and how they actually make x-intercepts. So you guys have some vocab words here. You can circle in your red pen, go zero, factor, solution, x-intercept. Okay? And the nice thing about these is that they're kind of interchangeable. A zero. So the zero is a zero of a polynomial. It gives you a remainder of zero. That x minus k is the factor, so it's your x minus your zero. So really zero and solution and then x-intercept are all really the same thing. So a zero of a function is an x-intercept of your function. And an x-intercept of your solution is, or x-intercept of your polynomial is a solution. So they're all kind of interchangeable. It's nice. Okay, so what we're going to use these is to graph, and I just have a little bit of a spot right here for you guys to put kind of those end behavior graphs that we talked about. Remember that we had some parabolas, so we had a parabola that faced up, we had a parabola that faced down, we had a snake that started down low and ended down high, and then we had one that ended down low like so. And remember is that I'm going to just make kind of a little table here for these guys, my degree and my leading coefficient. So remember, my degree is even. I have parabolas. So that's like an x to the fourth, an x to the 70th, some even number, excuse me. And remember here, if my leading coefficient is positive, it opens up, and if it's negative, it opens down. As I go on, if my degree, is odd, then I have these snakes, and these snakes are different here. They start down low. This one starts going down towards negative infinity. On the right goes to positive infinity. That is a positive leading coefficient. And my last one here is a negative leading coefficient. Okay, so it's kind of nice to see, hey, what should this graph actually look like? All right, so I look here at my first example. It says zeros. So what are the zeros of this function? That's what it asks you. My zeros here, if I set these guys equal 0. So if I set x minus 1 equals 0, I get x equals 1. And then if I set x plus 1 equals 0, I get x equals negative 1. So these are my zeros. I get x equals 1, x equals negative 1. So those are my x-intercepts. All right? So I have an x-intercept at 1 and negative 1. Those are my two x-intercepts. Okay? And what we need to do here is, you guys have these filled in, we're going to make a table to find out what this graph actually does. But to look at that, we have to ask myself, hey, what's my end behavior? What type of these graphs does it look like? So if I look here, I have an x to the third, but then I'm multiplying it by an x to the fourth. So really, if I multiply this guy out, I'm going to have an x to the fourth. So that guy is going to be a positive parabola that opens up. All right, so both these guys are going to be going towards positive infinity in the end. So now let's look. It tells us up here, this is the big part, I want you to highlight, circle this in. It says identify x values between and beyond each x-intercept. Okay, so if I look at x values that are between and beyond, the one that's in between is kind of nice. Let's go with 0. So I'm going to plug in 0, see what that shoots out. Beyond each would be like this way and this way. So I'm going to plug in like x equals negative 2, x equals positive 2, to find out what this graph actually does in that area. All right, so let's plug in 0. So I go f of 0. Is equal to 0 minus 1 cubed, and then 0 plus 1. 0 minus 1 is negative 1, cubed is negative 1, times 1 is going to be negative 1. So this guy is negative 1, so I get 0, negative 1. So does that make sense for this parabola that opens up? Sure does. All right, now I plug in negative 2, so I get f of negative 2. is equal to negative 2 minus 1, cube that, and then I have negative 2 plus 1. Okay? Negative 2 minus 1 in here is going to be negative 3. Negative 3 cubed is going to be negative 27. And then times a negative 1 here is going to be positive 27. So this guy gives me positive 27. So that's a big number, and that's all right. So that means I have negative 2 and positive 27 is going to be somewhere way up there, right? So that's what my graph is going to do. It's going to come in from here. It's going to go in through here. It's going to go in here, and we're going to find out what it does after it hits that last green dot. So let's plug in 2 to find out what this looks like. So if I plug in 2, f of 2 is equal to 2 minus 1 cubed and 2 plus 1 cubed. Or excuse me, not cubed for the last one. 2 minus 1 is 1. 1 cubed is 1. And then times 2 plus 1 is 3, so I get 3 here. So I get 2, 3, 1, 2, 3, and that one's on the graph. So this right side, it's not like a perfectly symmetric parabola this time. This right side goes up through here and kind of goes up in that direction. Kind of goes up a little less steep than the left side does. All right, so that's my graph of that parabola. Great. All right, so now if I go on to the back side of those notes here, it says turning points of a polynomial. And you guys don't have this in here, so you can draw this one in here with me. Let's draw in this polynomial. Let's go here, here, and here for my x-intercepts, and this graph's gonna tell us a lot here. Let's go for negative 4, sure, and let's go for negative 4. Go 0, 2 right there. So this graph starts in here, comes in, goes up, comes above the x-axis, goes back down, and then ends up going all the way up. Okay, so here it says local max and local min, and we're gonna talk about these for this graph in a second. Local max and local min is pretty actually self-explanatory. If I have a graph like this, the local max is like a point like right here. So that's a local max because it's higher than all the rest of the points that are around it. And then this is a local min because it's lower than the rest of the points that are around it. All right, awesome. So now it says estimate the coordinates of each turning point. So the turning point is, hey, where does this guy turn and start going to the positive or start moving around? So I see one right there, I see one here, and I see one here. Those are 3 turning points. So let's say, hey, that's 1, 2, 3, 4, negative 4. So I have 4, negative 4 is a turning point. This guy is 0, 2. And then my last turning point is going to be what? I think I meant to make it 4, negative 4. And excuse me, this first one is negative 4, negative 4. Awesome. So state whether the local turning point corresponds as a local maximum or a local min. So let's draw this guy actually out on this graph. This guy right here, would you say is a local max or a local min? He's a min. This guy, max, it's higher than all the rest of the points, and this guy is a min, it's lower. So all these are over here. List all the real zeros. So these are just the x-intercepts. So where are the x-intercepts? They're right here, 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 and here. So that's at x equals negative 4, negative 2, positive 2, and positive 4 are my real zeros. Excuse me, these are not 4s. These are 6s. This is negative 6, and this is positive 6 over here. My 4s were my mins and my maxes. Okay. Now it says determine the least degree the function could have. So look at this. This function ends up both going towards positive infinity. Okay. So the least thing that this function could have is this got to be some even degree, right? But if I look up here, it's got to have at least n minus 1 turning points. So it's got n minus 1 turning points. This has 3 turning points. So that means that my lowest degree that this could have is f of x equals x to the fourth, because it has 4 minus 1, which is 3 turning points. All right. So the lowest it could be is x to the fourth. All right, so that's just a little couple things about local max and local min. Main thing is for graphing those polynomials, finding the zeros, and then testing out those points to see what that graph does in between them and beyond. So please come find me if you have any questions. I would be more than welcome to have.